So in this demo, we want to wire up the save handling from our add edit form and see how we can use dependency injection related to that. Now, the initial straightforward way to do the save handling would be to drop into this add edit customer view model and new up an instance of our customer's repository, and then drop down to the save handling and call the update customer or add customer methods of that repository. However, there's a couple problems with doing it that way. One is testability. This is a hard-coded, not exposed dependency that the add edit customer view model now has. Any method that touches this object is going to be really hard to unit test because it's going to try to actually go out to the database and do things. We don't want that in a unit test environment. We want to be able to substitute a mock object. We also have another problem, is that this view model is newing up its own instance of the customer repository. And if you remember, over in our customer list view model, it's newing up a different customer repository. So the objects that get read in by those two can be completely separate objects that really represent the same rows under the covers. When you're doing that kind of thing, you really want a singleton model for that repository so that you're exposing shared state to the multiple view models that are going to use it. And that's where dependency injection comes in. So the first thing we'd want to do is change the code in our view model to take in a reference to an iCustomer repository. Now you can see this type is not coupled to the concrete type at all, just the interface, and provides a path for passing in a mock object in a unit test environment. We can go make a similar change to our customer list view model. And now, likewise, our customer list view model just takes in the interface reference and is no longer coupled to the concrete type. Now for this code to still work, we'd have to move up to the parent view model and pass that in. So we'd move up here to the main window view model, and we could new up the instance of the repository here, and then change the construction of those child view models to pass it in through the constructor. So this fixes the problem for our child view models in that they get passed in the appropriate thing at runtime, but they can have an alternate thing passed in a unit test environment. And they're only coupled to the interface now. But now our parent view model has been kind of corrupted because it now depends on a concrete type that it doesn't even use directly itself. So how do we fix that? Well, that leads us to using a container to do the resolution of all dependencies. I'm going to go ahead and use the Unity container because it's one that I've used quite a bit, but any container can do these similar kinds of things. First off, I'm going to bring in Unity by pulling in its NuGet. Now, when using a container, you generally have a singleton model for the container itself. So I'm going to wire up a simple helper for the singleton pattern here that I call container helper. The container helper class exposes a singleton instance of an iUnity container through a static property. And then it can also be the place that you do your centralized registration of any types that you want the container to be responsible for creating. In the API of Unity, what we do here is basically say, whenever someone asks for an iCustomer's repository, give them a customer repository as the concrete type. And this extra argument here, it's kind of a long named parameter, but to Unity, it basically means make it a singleton. So the first time someone tries to get an iCustomer repository from the container, it will new up one of these and satisfy any dependencies it has. And every subsequent time, it will just return the reference to the singleton. Now to use this, we would go back to the parent view model, the main window view model. We'll add a namespace for the Unity namespace. And then we'll change the way these child view models are created to use the container. And we use a resolve method in Unity specifying the type we want to create. When it goes to construct that object, it will satisfy its dependencies based on its parameterized constructor. So it will be able to construct and inject a singleton instance of iCustomer repository. Now, this parent view model doesn't even have to know about that dependency, so we can delete this line up here. Now finally, we can go wire up the save handling in our add edit customer view model. So now when we call save, we'll first copy the contents of our editing customer back into the original customer object that we held a reference to, with another helper method that pushes and pulls the right properties. And you could use a tool like AutoMapper for doing this kind of thing. Then, depending on our mode, we either call update customer async or add customer async on our repository, and then signal that we're done. Obviously, we'd need a little error handling in here in case those methods threw exceptions. With all that in place, we can run We can find our way to a customer, edit that customer, change their name, save, and we can see now it's changed. And if we stopped and restarted the application, we would see that that was actually a persistent change. So now that we have dependency injection and validation all wrapped up, I've got one more use case I want to fit in, and that's to be able to search and filter on the customer list here. So we'll do that in one last demo, and then we're done.